Hello class. In this video I would like to go over problem 55, which is in our packet on page 12. Alright, well, this problem has to do with sales, and it reads, the sales S, which is in thousands of units, of a new CD burner after it has been on the market for T years is modeled by S of T is equal to 100, quantity 1 minus e to the kt. It also says that 15,000 units of the new product were sold in the first year. All right, well, this problem is a little bit different from some of the earlier problems we did in class because the exponent here, or the variables on the right-hand side, are two. We have a k and we have a t. All right, now, question A is asking about completing, or wants you to complete the model by solving for k. All right, the way you do that is you first set up the equation, and we need information that that's going to help us figure out what k is. And that information is found in the last sentence of this paragraph here. It says that 15,000 units were sold during the first year, or when time is equal to 1. All right, so I'm going to plug in 1 for t, and 1 for t, and that gives us 15,000 units. So put a 15 here, equal to 100, quantity 1 minus e to the k, and then times 1, because t is equal to 1 after 1 year. Okay. Now, the reason I didn't put 15,000, didn't put 15 followed by 3 zeros, is because this equation says that S is in thousands of units. All right. So just by simply putting the 15 there, that represents 15,000. Okay. And also, I know that this looks like multiplication, but it's not. It's function notation. So it's S of t, the sales when time is equal to 1 year. Okay. So anyway, so you plug that in and you start solving. All right. So the first thing to do is divide by 100 both sides. And once you do that, you get 0.15 is equal to 1 minus e to the k. K times 1 is just k. And then you subtract the 1 both sides. And we get, let me remove this. And we get negative 0.85 is equal to negative e to the k. All right, at which point we're trying to isolate the e to the k. So we divide by negative 1, and we get 0.85 is equal to e to the k. Okay, now we have to get rid of this exponential. We're looking to solve for the k. So the way to do that is to take the natural log of both sides, and that's going to cancel out with the e on the right side, leaving just the k. So the answer is whatever ln of 0.85 is. So there it is. K is equal to negative 0.162. All right, now that's the answer to the first part. Actually, the first question here, it does say complete the model by solving for k. We solved for k, but now we have to complete the model. All right, completing the model just means taking this k value and replacing it for k. All right, so this is our new equation. All right, so I've substituted the k value that we got into k. All right, this is my new equation, and now let's take a look at what the next question is. The next question wants us to sketch the graph of the model. All right, sketching the graph of the model. Well, in class we talked about how to sketch it by finding the slope and the vertex. All right, so the first thing I'm going to do here is I'm going to distribute the 100. 100 times 100, 100 times negative v to that exponent there. We get this expression here. And the quote-unquote slope in this problem is the number in front of the base. In this case, it's here's the base, so it's negative 100. And the vertex here is 0. There's no, well, it's h comma k, and there's no h here, so it's 0, comma k. There's nothing over here, but the 100 is a k. It's just not in the right order. So the vertex, once again, is 0, comma k. So 0, comma 100. Okay, that's the vertex. All right, so we sketch the problem, or the xy plane, and then we plot the vertex 0, 100, put the dot, and then put the vertical dots and the horizontal dots, and that's my new xy plane. And the vertex is negative 100. So we go down and we put a dot right here. Okay, all right. But now this is an exponential, so a normal exponential would go up here. Now this one, we have to flip the regular exponential. We got to flip it down because the slope is negative. The quote-unquote slope is negative. But that's not enough. The exponent is also negative. So we're actually going to flip it twice. The regular exponential, we're going to flip it below, but then we're going to flip it over the sideways. So this is what the correct graph should look like. Okay, so the slope is negative 100. We drop down 100, put a dot, and that's our curve. Okay, so then that's the sketch. Now let's take a look at question C. Question C says, use this model to estimate the number of units sold after 5 years. So you can, just by looking at the graph, or the sketch that we did, well, it says here that as time goes on, and x-axis here represents the time, the longer this CD burner has been out on the market, the cells are going to start slowing down. And this is what the sketch is representing. Okay, so it'll always go up, but just less and less, or more and more slowly. The cells are just gonna diminish as time goes on. All right. So now, once again, it says estimate the number of CD burners sold during the first 5 years. Sold after after 5 years. All right, so we have the equation. We're going to find S of 5 and put 5 in here, substitute 5 for t, and we're going to work it out. If you have a basic calculator, maybe you can do e to the exponent, multiply it by -1, and then maybe add a 1 if you have like a basic calculator. So, but we have to figure out this parentheses, and then at the very end multiply it by 100. All right. If you have a more advanced calculator, I guess you can plug in everything directly as it says there. But the answer that I got here is 55.510. Now, does this mean that only 55 CD burners were sold? No, not quite. Remember, the top of the equation says that it's in thousands of units. So 55, we have to move the decimal 3 places here. 1, 2, 3. So in reality, 55,510 units are sold after 5 years. Okay, and that is it.